Welcome Calculus 2 students. We are going to do the method of partial fraction decomposition in order to integrate a rational function. Now I want you to notice our example 1, we have a polynomial over another polynomial. What I'm going to do with this is I'm going to factor that denominator into its partial fraction decomposition, and then it will make it so that it is super duper easy to integrate, and it will make our life so much nicer. Okay, so this is just another technique that I'm learning, and I get a little practice with it, and that's all this section is about. What I'm going to do first in this particular problem is I'm going to go ahead and see what this denominator factors into. So if I factor out that x, I'll get x squared minus x minus 2. Then I'm going to factor that even further into this x times x minus 2, x plus 1. And then I will need to figure out how this thing goes into a entire decomposition. So let me get that set up for you. Alright, I've got this little boy set up for you now. What I'm going to do is I'm going to multiply both sides by this entire denominator, so that on the left hand side I'll get 3x squared plus 7x minus 2 equals, and that'll be a times the x minus 2, x plus 1, and then the b times the x times the x plus 1 plus the c times the x and then the x minus 2. Now I'm going to multiply all of this out, and I'm going to collect powers of x and write that down for you. Alright, and what I have is that a plus b plus c now equals 3. I have minus a minus 2b plus c's got to equal 7. And I have negative 2a equals negative 2. Oh, you know what? I know what a is. He's a 1. Now, I will probably put these into my calculator and do a matricy solve of these to get a, b, and c, but I just went ahead and wrote down a because I saw how sweet he was. Alright, so let me go get a, b, and c. I went and got a, b, and c, and now here is the partial fraction decomposition. They want me to integrate that, so I'm going to write down that integral and how I'll break it apart. Here's the integral broken apart with partial fraction decomposition. Notice that this is just the natural log of the absolute value of x, pretty sweet, minus 2 natural log of x minus 2, those absolute values of course, plus 4 natural log of the absolute value of x plus 1, plus some constant c. Using my properties of logs, I can write this as 1 log, and let's do this. Absolute value of x will have to stay like this. This will go in the denominator squared, so I can drop the absolute value symbols because it is definitely going to be positive. And this one is to the 4th power, so that's definitely going to be positive, so I can drop those absolute value symbols. And plus c. All done. That one is really nice. Our next problem involves partial fractions where we had a repeated factor. And if you'll remember from your college algebra course, those repeated factors require a little something extra that I need to do. So let's review that. I'll go ahead and factor that denominator. Here we have it. For each of those repeated factors, I will have to have a term for those. So notice not only do I have the b over the x squared, I also have to have an a over x. If it would have been a cube, I would have needed an a, b, and a c with powers 1, 2, and 3. I'm going to multiply both sides by that denominator, and I will get 5x squared minus 3x plus 2 equals a times, and if I multiply by that denominator, I'll have an x and an x minus 2 plus b times just a plain old x minus 2 plus a c times x squared. Now what I'm going to do is collect coefficients of each of my powers of x. Alright, you will get for a, b, and c when you 1 and 4. Sorry about that, that's a negative 1. Alright, now what I'm going to do is I'm going to integrate this thing. Alright, here we have the integral broken apart into its partial fraction decomposition. This is going to be the natural log of the absolute value of x, and this is just going to be plus 1 over x. This is plus natural log, and we'll go ahead and say 4 absolute value of x minus 2 plus c. Then making this look a little prettier, 1 over x natural log, and I think I'll just need I don't need a division symbol. It's just going to be this to the 4th, because that would be positive, plus c. And that is it for example 2. In this next example, or 2 examples because they don't let it be just one, I am going to look at partial fraction where it doesn't do just simple linear factor. It reduces down to a quadratic, and note that I need that in that numerator. I'll need an ax plus b term in order to figure that out. So we will start by working on example A. I'll go ahead and factor that denominator. Alright, so this one factored completely. I'll just use what I learned in the previous example, and then I had linear factors. This is how this one would break apart. Alright, let's look at this next guy. He's already factored for me. I have a repeated root here. So x minus 2 quantity squared plus, and then I'm going to need a cx plus d because this next one is a quadratic that doesn't factor. And if I were to try to do the partial fraction decomposition, this would be what I would use. Alright, on to the next one, because they didn't ask me to actually solve this, they just asked for the setup. In order to do the partial fraction decomposition for this particular problem, I'm going to need to break this apart with my x minus 2 and a here, and this one will be a bx plus c because this particular quadratic does not factor further, which means that I'm going to multiply both sides by this denominator and then collect my powers of x on the right hand side. So that's what I'm going to do for you. I will set this up as a system, and then I will solve for a, b, and c. This is what I get for a, b, and c. The next thing I need to do is set this up as an integral now. Alright, now this second integral here is a little messy. If I were to let u equal to x squared minus 2x plus 3, du would equal 2x minus 2 dx. So I'm not exactly there yet, but I could break this into 2x minus 2 plus 3, and that would still be there, and that would allow me to be able to integrate this thing. Okay, I now have du over u on this second integral, which is just going to be a natural log, so that one's good. This one is not good. I'll need to complete the square so I can get some sort of u squared plus an a squared, and then I'll be able to integrate that one. So I'm going to rig this second one. This second one is set up perfectly though. Alright, This integral is going to be an inverse tangent with my u being x minus 1. Notice that du equals dx here, and my a is going to be the square root of 2. So I'll have that inverse tangent, and I will just use that formula for inverse tangent. Alright, there she sits, beautiful as can be. Next up is just a summary of everything that we've done. Nice little summary. It's in your instructor notes, so give you kind of clues as to what to do whenever you are approached with a particular problem that you need to integrate. If you have any questions, see me at the Collaborate.